Alrighty, so on page 4 of our week 3 concept check, where we're talking about electrons, we're going to go through our third type of electron configuration called an orbital box diagram. In here, remember from the lecture, each electron is going to be represented by an arrow. And so we have a couple of things to consider when we do orbital box diagrams that we don't have to consider with the other types of electron configurations. Specifically, the Pauli exclusion principle, which says that the two electrons in an orbital are different. And so we'll show that doing an up and a down arrow. And then we'll also have to deal with Hund's rule, which says that when we come to a set of orbitals that are the same, such as a set of p orbitals, let's talk about the 2p, you put in one electron into each orbital before you fill up. So we're going to have to keep those two things in mind. But other than that, we're just counting to the number of electrons for our element. And so sulfur, we look on the periodic table, and we see that sulfur has 16 electrons. And so all I've got to do is count to 16. I've got to put 16 arrows in. Again, I'm going to follow my filling order, but I'm also going to use arrows, and I'm going to do up, down within a box. So when I come to the 1s box, I go 1 up, 2 down, and I fill that box up. Remember, that's the lowest available subshell. Then I go to the 2s, which has 1 box. So I go 3 up, 4 down. Now, when I come to the 2p subshell with 3 boxes, this is where Hund's rule comes in. I go 5 up, 6 up, 7 up. Then I go 8 down, 9 down, 10 down. 11 up, 12 down. And again, when I come to the 3p, I go 13 up, 14 up, 15 up, 16 down. So that would be the orbital box diagram for sulfur. Let's go ahead and do iron, which has 26 electrons. And so again, we're just going to count to 26 the same way we did before. So I go 1 up, 2 down, 3 up, 4 down, 5, 6, 7 up, 8, 9, 10 down, 11 up, 12 down, 13, 14, 15 up, 16, 17, 18 down, 19 up, 20 down. When I come to 3D, again, I'm going to go 21, 22, 23, 24, 25 up, and then I pair one of those to get to my 26 electrons. Again, you've got to follow Hund's rule. Let's do one more example. Here we're going to do germanium. Germanium has 32 electrons. And so again, 1 up, 2 down, 3 up, 4 down, 5, 6, 7 up, 8, 9, 10 down, 11, 12, 13, 14, 15 up, 16, 17, 18 down, 19, 20 up. Again, I go 21 through 25 up, 26, 27, 28, 29, 30 down. And so now my last two end up in 2 separate 4p orbitals. So again, make sure that you are aware that in an orbital box diagram we use arrows to represent electrons, that we have them spin pairs, and we do that by showing 1 up, 1 down. Convention says we do ups and then downs. And then I think the thing that is what's going to, that's the toughest for students to remember is making sure that when they come to a set of boxes, either in a p orbital or a d orbital, put 1 electron in each of those boxes before you start to pair. All right, so that's page 4. Thank you for your time. We'll move on to page 5.